In this bonus objective, we're going to cover something we mentioned before in a previous learning objective, but now we're just going to do it in a bit more detail, and that's composition of functions. All right, so we talked about this when we were checking inverses. We had to put one function inside of another. All right, and this was, if it's simplified down to x, they were inverses. But you can do that for things that aren't inverses as well. Just putting one function inside of another is known as composition of functions. All right, so there's two different notations you could see. I prefer one over the other. All right, the more complicated one is this f open circle g. All right, it's like the formal notation for a composition of functions. All right, I'm not going to give you this notation because I prefer the other one that just looks like this. And that makes sense because I have my f function with its parentheses. And inside of the parentheses of my f function, I have my g function. All right, so I'm literally putting the g function inside of the f function. All right, so that's the notation I prefer. But these things are the same, they're equivalent. So if you're looking through textbooks and stuff, you might see this. All right, but I'm going to use that one because I think it's more straightforward about what's happening. All right, so let's say f of x equals 2x plus 1, and g of x equals 5x minus 2. Find f of g of x. All right, so g, that whole g function, this whole thing, is going into the f function. And what does it mean when we plug in something into a function? It means we replace the x value with that thing. All right, so this is going to be, the 2 is going to stay. Instead of this x here, I'm going to replace it with the thing that's getting plugged in, 5x minus 2. And then I have the plus 1. All right, so all that changed was this x here got replaced with 5x minus 2. And I just have to use good practices of simplifying. I'm going to distribute this 2 in and combine anything that we can. In this case, we can combine these numbers at the end to get that. Right, so this is all we have to do. It's just kind of working on your algebra of combining terms and your function notation. Right, but just putting one function inside of another. All right, here's another one. All right, f of g of x. Sometimes these will be written as g f of x. All right, but in this example, same as the last one. All right, g is going inside of f. So I'm going to take all of g of x and put it in for the x's, all the x's in my function expression. This 1g is going to go into those two places. All right, so I'm going to have, instead of x squared, I'm going to have x plus 3 squared plus 2. Instead of x, I'm going to have x plus 3. All right, so that's the first major step, is just correctly putting the whole g expression into the f expression. And one thing that's a little complicated is they both have x's in it. All right, but again, just think about this as a kind of a box of things you're putting into these two boxes, kind of helps solve that issue. All right, x plus 3 squared. All right, a lot of people write that as x squared plus 9. All right, but x plus 3 squared just means I have 2 copies of x plus 3. And that means I have to FOIL. All right, so when I FOIL that out, get x squared plus 3x plus 3x plus 9. And then 2 times x plus 3 I have to distribute. I'm going to get 2x plus 6. Then I combine all my like terms. I have a couple x terms and a couple numbers that I combine. And so x squared is going to stay by itself. 3, and 2x is going to give me 8x's. 9 and 6 gives me plus 15. And that's the whole problem. Again, just putting one expression into the other and then simplifying as much as possible. All right, just get used to the kind of order and how things can work. All right, here we actually have 3 different functions, f, g, and h, and we're just going to do it in order. So the first thing we do is take f and put it into h. Then we're going to take that whole thing and put it into g. All right, so first let's just look at f into h. So I'm going to take my f function. I'm going to put it into h. Right, so I'm going to take all of this and put it in there. That's going to give me the square root of x plus 1. All right, so that's f into h, but I still haven't done the g part. All right, so now I have to take this whole thing and put it into g. So that's going to give me, all right, the 2 is going to stay there, and all that's getting plugged in like that. Right. So x plus 1 got put into the square root, and the square root got that 2 in front of it. All right, so that is one thing at a time, f into h, then h into g. All right, here's one for you to try on your own. All right, have our f and our g, and here you're finding g of f of x. Just make sure you pay attention to the order. F is going into g. All right, so go ahead and try this one on your own. And here's what you should get. So we're taking all of f, this 3x minus 2, and putting in for this x here. All right, so the 2 is going to stay, and the 7 is going to stay. All right, but this box x is getting replaced with 3x minus 5. All right, then we distribute, and we combine those two numbers by combining like terms. All right, we get 6x minus 3 as our final answer. All right, so for this learning objective, you're going to do problems on delta math. All right, you're just going to create new functions using composition. So just like all these examples we were doing, I look at which functions you have, and then create the composition.